The AK is not the result of a brilliant flash of insight, but the product of a decade-long rework of defective blueprints and failed prototypes. The technical history of the platform in 1946 began with an official demand to shut down the project due to its total unsuitability. The first samples had nothing to do with reliability. The separate receiver deformed during firing, and the borrowed automation components failed to work in tandem. During testing, units jammed after the first 10 shots, and accuracy did not meet even the minimum Army standards. What is called the base today is a series of forced corrections to a system that was initially inoperable. It was not a triumph of engineering thought, but an attempt to force raw iron to perform the functions of a weapon. But the very first production run showed that the real problems were only beginning. The factories produced a batch of weapons that literally bent in one's hands. Soviet industry surrendered to an ordinary sheet of steel, turning the first series into a heap of tin scrap. The launch of the first model into mass production in 1948 was a technical disaster. The design bureau bet on a stamped receiver to make the process cheaper, but the factories could not maintain the tolerances. The sheet steel was too soft, and the welding technologies were primitive. As a result, the receivers twisted from overheating. The geometric axes of the components shifted, and the bolt simply stopped moving in its grooves. Welds burst after a few magazines, turning the rifle into a piece of useless metal. It was an industrial paralysis. The Army received a weapon that physically could not survive even the primary inspection due to systemic design defects. To save the project from total closure, engineers had to make a shameful retreat to 19th century technologies. Engineering capitulation, the transition to manual steel cutting due to the inability to master modern technologies. In 1951, the project was saved in the most primitive and expensive way, by abandoning stamping. Instead of light sheet metal, engineers began using solid steel forgings, weighing 4 kilograms. Each receiver was literally gnawed out by a milling machine, just like in the days of the First World War. This solved the strength problem, but created a new one. The rifle became critically heavy. The technological weakness of production was shifted onto the shoulders of the infantry. Soldiers received an overweight weapon that became reliable only because it was made excessively massive, signing off on the inability to work with the high tech of that time. But while the infantry lugged around extra kilograms, the paratroopers received a modification that began to maim their own faces. A folding mechanism that crushes the cheekbone and knocks out teeth with every shot. For paratrooper units, a version with a folding stock was created, which became an example of a complete disregard for ergonomics. The thin steel struts had no surface area for support or cushioning. When firing a 7.62 round, all the recoil energy was transmitted by a narrow metal edge directly into the shooter's jaw. This led to constant hematomas and facial injuries when attempting aimed fire. Moreover, the hinge assembly became loose after only a few hundred shots. The resulting play was impossible to eliminate in the field, turning shooting at distances over 150 meters into a haphazard scatter. However, even with such defects, the iron began to manifest its true, frightening durability. Only after 12 years of torment did engineers force the metal to work as it was intended at the very beginning. By 1959, the technological deadlock was overcome. Stamping was finally tamed, creating the AKM, the very model that is mistakenly taken for the original sample today. The weight was reduced by a full kilogram by returning to sheet steel, but this time with the correct geometry and hardening. A hammer retarder was introduced into the design, which stabilized the automation, and a slanted compensator was added, which eliminated the wild muzzle climb. This was the moment when the platform finally shed its status as a heavy semi-finished product and achieved that balance of weight and service life that made it suitable for mass operation. The platform gained stability, but a new threat came with the attempt to make shooting comfortable for untrained recruits. The change of caliber was an admission. The Army is incapable of training soldiers to control the recoil of a normal caliber. In 1974, a transition to the low-impulse 5.45 cartridge occurred. This solved the accuracy problem but deprived the weapon of its main advantage, stopping power and predictable ballistics. The light bullet with a high muzzle velocity became extremely unstable. Any contact with grass, small twigs, or foliage changes the flight trajectory. We got laser accuracy at the range, but in real greenery conditions, the bullet began to ricochet off dandelions. Moreover, the reduction in caliber required tighter tolerances in the gas block, making the system sensitive to powder quality and timely cleaning. The attempt to make this caliber even more compact led to the creation of a sample that blinded its owner faster than it hit the target. Shortening the barrel turned the rifle into a useless flamethrower with zero ballistics and service life. The development of the AK-74U is an example of ballistic suicide. Engineers shortened the barrel to a critical minimum, because of which the powder charge simply did not have time to burn. The result? A huge ball of flame with every shot, which burns the shooter's retina at dusk and gives away the position for miles. The muzzle velocity of the bullet dropped so significantly that the cartridge energy at distances over 100 meters does not guarantee the penetration of even light obstacles. The barrel overheats after 2 magazines, causing thermal deformation and wild scatter, turning the automatic weapon into a noisy accessory for point-blank shooting. But this is exactly where the paradox began. The worse the conditions became, the brighter the platform's primitive reliability shined. The moment when the Design Bureau finally found the balance between compactness and stopping power, correcting the mistakes of past decades. The 100th series became a surgical response to the chaos of previous models. Engineers finally got rid of rotting wood and fragile bakelite, replacing them with impact-resistant glass-filled polyamide. This solved the problem of climatic deformation of the furniture and gave the weapon the necessary rigidity. In models like the AK-103 and AK-105, they managed to combine the ballistics of a full-size barrel with the controllability that the shortened version so lacked. The platform reached its technological ceiling, the mechanisms worked with ideal clearances, and the barrel life allowed the weapon to be used hard and fast without loss of accuracy. While the world admired this stability, modern improvers were preparing a new tactical dead end for the platform. The flagship of the Ratnik program, which fears dirt and loses its zero due to questionable design whims. The modern stage of modernization became a step backward in terms of survivability. In the pursuit of Western standards, Picatinny rails were hung on the rifle, but this was done at the expense of the reliability of basic components. In the AK-12, the gas tube was made non-removable, which deprived the soldier of the ability to fully clean out carbon buildup, the main factor of corrosion. The diopter sight and the receiver cover, secured by a pin, inevitably begin to develop play over time, shifting the point of impact. This weapon began to look modern, but lost that very unpretentiousness for which the platform was valued for decades. The pile of plastic only masked the refusal to solve fundamental mechanical problems. However, behind all these layers of plastic and marketing lies something that cannot be killed by any engineering errors. The rifle became a world standard not because of accuracy, but because it ignores death where other systems give up. The AK conquered the planet because it does not care about the absence of maintenance, logistics, and shooter skills. In conditions of real chaos, where there are no sterile armories and professional masters, it is the only mechanism that continues to work. While complex Western systems require special lubricants and delicate cleaning, this iron skeleton digests sand, silt, and cartridges of questionable quality. It became the benchmark not in engineering offices, but in the mud of local conflicts, where the survival resource of the iron proved more important than its accuracy on paper. It is the most mass-produced tool of war, which defeated time through its absolute tolerance of abuse. In the end, decades of struggling with defects gave birth to the most effective mechanism in human history, where primitivism became a sign of genius. The genius of this system is not in the blueprints of 1946, but in the fact that in the end, only that which works in the mud remained. The true greatness of the platform manifested itself when everything superfluous was cut away from it. The primitivism of the design, which initially seemed like a weakness, became the main strategic advantage. The AK rifle is a triumph of redundant reliability. Huge clearances between parts allow the mechanisms to eject dirt and carbon right during firing, rather than jamming from the first grain of sand. The simplicity of disassembly in the dark, the barrel life, and the omnivorous nature of the automation made it the standard for 50 armies of the world. While competitors chased complexity, here crude functionality was brought to perfection, turning the weapon into a fail-safe tool that is understandable even to a teenager. History has come full circle, from the tin plate disgrace of the 40s to the absolute Iron Throne in the hands of every third soldier on the planet. In real combat, rails and attachments are not important. Only the shot that will happen in any case is important. The result of this technical audit is simple. The AK defeated the world not by elegance of lines, but by brute force and tolerance of chaos. All attempts to improve the platform with modern materials and complex components only confirmed one thing. The old base from 60 years ago remains an unreachable peak. Modern modifications are just an expensive way to mask reliable iron, which at its core does not need marketing. Ultimately, when technology fails and logistics collapse, only bare mechanics remain in hand, ready to fire at any moment. Iron does not lie. In the end, in the mud and fire, only the simplest survives.